So the Complete AI Bootcamp is built with keeping in mind that we have a lot of different small events that we keep doing that you might have seen elsewhere as well. With this event, we wanted that you get one overall picture in terms of what you need to know in terms of the concepts related to AI, LLMs, etc. Additionally, we will also cover agentic AI, which will be covered in day two. So today is day one. Today we'll be spending 2 hours, which is more towards your concept building related to AI. Now, if you are a student, of course, it's a great start for you to get into AI very early on as well when you're starting your career. Even for working professionals, I think all of us have seen how every CEO, every founder is urging their employees and every person to sort of learn about AI and implement AI in their work, no matter what your role is, right? So with this 2-day session, we hope that you're able to gain enough insights that at least you can kickstart your journey. Of course, you do need much more guidance if you want to get into deep AI related roles. But at least to kickstart something, this should be a good starting point for all of you, right? Before I hand over to Arun for today's session, few ground rules. You will get a certificate for these 2-day sessions if you share your learnings over LinkedIn. So the idea is that we want to understand if you've gained learnings or not, or we don't want that a person who has just joined in for the sake of it and is not paying attention is given a certificate, right? We want to legitimize it by ensuring that you share your learnings on LinkedIn. Ensure that you tag product space as well, right? And tomorrow, towards the end of the session, we will be sharing a form wherein you will be able to share links to your LinkedIn posts. Okay. We will also share that particular form in a mail on Monday morning or just after the session tomorrow as well. So you can fill up your LinkedIn links as well in terms of what you've posted. Okay. So that's one. Number two is we will be sharing the feedback form as well towards the end, which is useful for understanding your attendance for both the session. Okay. All of these will be used to ensure that you are given certificate. We would need this data in the forms that will be circulated. Next, we will also share all the resources that you need in tomorrow's session, right? So we have curated a huge resource library as well, which will contain learnings from all of these 2-day sessions. Again, that will be shared after tomorrow's session itself, right? So hope all of those things are clear. If there are any more questions, you can feel free to share that in the chat in the next 2 minutes while Arun gets started as well, and I will answer them in the chat. Arun, over to you. And
Fantastic.
so,
Yep.
quick intro about Arun as well. So he is a senior product manager at Microsoft. He has been building AI products as well and has also mentored a lot of folks who have transitioned into AI product management related roles, right? So I think you're in great hands today. And yeah, Arun, over to you.
Fantastic. Thank you so much, Sakshi, and thank you, Product Space team. In all honesty, 6 hours or 5.5, 6 hours of bootcamp is not enough for covering or getting a head start on AI, but then it is a great endeavor, at least to folks who are fascinated by AI, but at least want to have a kickstart in terms of AI. I know the theory and I know the basic applications, and now I want to do it on my own. So this is a fantastic opportunities that ways. I'll try to do my best in the next 2 hours, not exactly 2 hours, but 1 hour and 52 minutes because I have a hard stop at 8. But I'll try to do my best to give you as much as I can. And would love to see your feedback and how we get the kind of LinkedIn responses um, from these 2 days. If we want to have a day 3 and day 4 of boot camp, as we said, we can keep doing this boot camp for probably 25 days, if not 100 days back to back, every day 2 hours. We have so much of content. But without further ado, first of all, thank you so much. Good afternoon, good morning, good evening from wherever you are joining us from all around the world. It's a privilege and it's a honor to be talking to you and for you to be spending this time with us over the next 2 hours. So thank you for joining us. And I am hoping we'll be able to deliver value and you find the next 2 hours resourceful, right? So we have spent enough effort to make things impactful for you. And we only hope it kind of lands that way. With that, let me get started. So, on the day one of this workshop, I'll be covering AI fundamentals. And when I say AI fundamentals, this is how the agenda is going to look like. So I know we have a very strong community and a loyal community. So when we have a community, we know people are there who have in the past been members of cohort but still join us. Again, you are welcome as always, but maybe this might be a quick revision for you, and you would have read all of this as the part of cohort, so it is just a quick revision for you. You can do better things with the next 2 hours if you think you are comfortable with all of these. For those who are joining us for the first time, I'll start by talking about the AI PM role in general. The idea is not to show the salary slabs or how this is charging a premium salaries, right? But the idea is to let you know if I just go into my LinkedIn today and if I try to search for AI PM roles, the number of jobs which are clearly calling out AI PM, how that is increasing and how the top influencers on product management are talking about this role, how they think these rules are changing and what needs to be done. I'll also share some bit of my personal experience from Microsoft in terms of what we are seeing when we are having these recruitments happening for AIPM roles, what sort of interview questions are being asked. Then I'll move on to the second part of the session, which talks about not everything is open AI and not everything is all the problems in the world don't need to be solved with generative AI. So as soon as someone tells you, hey, let's look at this problem and how would you solve it, don't tell the first thing that I'll make an agent and I'll run and create an open AI bot for you and it'll solve everything for you. I love this meme which says, I would love Gen AI to do my household chores and over the weekend wash my utensils and do my dirty laundry, which of course it cannot do. So not all the problems are solved by that. And it's very important that we as people who solve real world problems or at least aspire to solve real world problems are able to distinguish between what should really be picked up by AI versus what can we pick on ourselves. We'll then move on to the meat of the things where from the early days to now, how has AI evolved, right? And what are the technologies underlying which were solving all these problems much more efficiently than generative AI, right? So we'll talk about machine learning, deep learning, a bit of transformer and generative AI. I'll try to go at a surface level without going into the implementation level of what is machine learning, how is it different from deep learning, and with deep learning, what were the limitations that made us move towards transformer based architectures, which is chat gpt. And I'll explain you when you write a prompt, when I say, hey, I want this answer from a perplexity or a claude or a chat gpt, how does that work? And finally, I'll try to leave you with a AI product or a AI PM product roadmap, how your learning roadmap needs to look like, right? And what is a structured way of learning AI if you're doing it on your own. Of course, that's not to be said that's the only way. Everyone has their own way, or and some folks like experimenting and just upskilling. Others like to do it via certifications, and the rest of us find our own way. So we'll give you a roadmap that has potentially worked out well for us in the past, and then you can of course have your own, right? So I hope that sort of agenda makes sense for everyone. Having said that,
Uh,
let's get yeah.
yeah, Arun,
So
just FYI for you, we will not have
yep.
a break from product spaces side today. So we can just
Yeah.
have the break for Q&A. Yeah,
Yes, yes, and that is what I was planning to do. So
sure.
I will also not be entertaining questions in between. We will go with the assumption that the multitude of hundreds of folks who have joined us are here for content, and we'll try to deliver as much as content that we can. I have these 6 sections that I'm planning to deliver in the next um, 2 hours or so, and I've kept it six consciously. Knowing that there can be 5 to 7 minute Q&A break after each of the sections. And now you can do your math. That kind of lands us around the 110, 120 minute mark. So I'll try to cover session for 15 minutes, 18 minutes each, and then for a 4 minute break. I will not be allowing folks to come off mute or off cameras to answer your questions. We will only take questions that Shakshi lets me know that, hey, these are the questions which are most liked. So you might want to put your questions in the chat, and the questions that sees maximum number of likes or thumbs up, Sakshi can reiterate that for me and we can pick it like that. Right. So, Sakshi, I hope that works, right?
Yes, yes, definitely.
Okay. I think I lost my screen share, so let me do that again. Yeah. You'll need to let me know in between if my screen share goes away and if you're able to see it, right? Just interrupt me whenever I see that. Okay, let's start with the AIPM role. Of course, all of you are aware of the facts and know-hows of AI is causing a lot of job cuts, and there are plenty of rounds of layoffs that are happening. Plus, there is a clear uptick in terms of investments that these companies are making in terms of AI infrastructure and AI capabilities. Like if I talk of Microsoft, Microsoft alone has made quarterly around 25 billion, which is, if you look at the Indian landscape from where we are operating out of, we as in product space in India, the largest of companies, it's very difficult to have their overall valuation reach up to 25 billion, whereas companies like Microsoft are investing quarterly in that level of readiness, right? And I'm sharing this report. So if you see the use or adoption of generative AI is across the organizational hierarchy, highest with the leaders, medium to 50, around a 50% or a 46% with managers, and the frontline employees, which are most susceptible to job replacement, are probably the least users of AI. And that kind of gives you a clear indication of why I'm talking about this graph here, right? So why is a particular type of job category or a particular type of role more susceptible to replacement than the other. It's a clear indicator that why companies are not eliminating leaders or mid-level managers who are fluent or who are comfortable with AI versus those who are not adopting it, right? So and this is the reality of it, right? So we all have seen, or we have, if not seen or experienced it firsthand, we have at least heard somewhere in our immediate network that um, there is an eminent shift in structural learning and structural employment. And when we say structural employment, it is about the skills that individuals bring to the table, right? So structurally, what a PM needs to do or was doing probably 3 months or 6 months, not 3 months, but 6 months and before, is totally different to what a PM needs to do today. And if I think about that in terms of uh, the skills, it's not about the traditional skills are going away. And some of you might hear this me from on my LinkedIn post as well. I always say the PM traditional skills of prioritization, business stakeholder management, customer obsession, and finding the right problems to solve is as relevant as it was yesterday. It's only about becoming 100x PM where you are showing those skills. Plus, you are the leaders in the world of AI where you are using these tools, capabilities, and functionalities to your advantage, right? So how does the role look like, right? Let me just, and this is the report. I'm just sharing this because if you click on the deck anywhere, you'll be able to see the links to whatever you have searched. This is just a LinkedIn search from today morning, right? And if you see the job of product manager AI, right? These are some of the United States based roles, and you can look at in your area also. Just a 30-second pause for you to look at this JD and the salary bracket, right? Plus, the most important thing, the skills that are being sought after. So, AI initiative, customer AI assessment, and business reviews around the growth opportunities of AI, right? Similarly, if you look at and this is a more a B2B role. If you look at B2C role, which is Figma, 3+ years of product management experience. Of course, I'm assuming most of us would have that here. Proven track record with iterating AI features that drive impact. It's no more about driven impact, it's about driving impact with AI. Experience working in fast-paced and scrappy environment, experience in AI model learning, evaluation, and iterations. How do you keep your model up to speed? How do you keep the latency in check? How do you ensure you are using the right model for your use cases? because everything from ChatGPT to Perplexity to Claude to Figma to Miro are all wrappers on top of these AI models, right? So how do you ensure that your models evaluations and iterations are top notch? Ability to clearly communicate and articulate with stakeholders, and in an AIPM role, the stakeholders might be data scientists, the stakeholders might be um, machine learning experts, or the teams which are doing product analyst roles who are looking at AI metrics week on week, month on month, right? And affinity towards a startup environment, of course, that, okay, I think I lost my screen share again. Let me.
Is it happening because of some issue from our end, Arun?
I don't know. But it's okay. I kind of get it whenever I lose it, so I'll be quickly able to share
Okay.
it. That's should not be a problem. But yeah, so this is, and you all can, right after this session, not at this point of time, but you all can also just go around in the areas where you are based out of. You can just look at the roles that are there. A few common elements that you might see is one, prioritization and stakeholder management with AI, which is data scientists, machine learning experts, and tech debt of AI features. Second is understanding models, which model to pick, how to increase the latency, or decrease the latency and increase the cost, uh, to revenue to cost reward, like maximum revenue optimization per query cost. Another thing that you might come out very commonly is improve the quality or accuracy of these model and the customer satisfaction rate with some of these AI capabilities. And most importantly, which is something that is most likely evaluated in AIPM interviews also, is experiment fast and try and validate a lot of prototypes with these AI tools. So that is what has democratized. We see all around us tools like Lovable, Replit, Cursor, Notebook, LLM, Google Storybook, from the entire 4D journey of a product manager, right? Which is discover using Perplexity deep research or Gemini deep research, to defining using maybe a chat PRD or a Claude canvas, and then delivering it with a prototype of Google Stitch or a Visily.ai or UXZard, and then developing and deploying the product on one of these lovable Replit, is an entire journey that is being evaluated. So that is, all these tools make you experiment and churn product faster. If something is not working out, it is easier to do iterations with AI. Are you skilled enough to do it or not, is what is being evaluated, right? So that is how the role is evolving. What exactly is expected out of a role? I think it's not very clearly defined, because as I showed you two JDs, and you might look at a lot of JDs on your side also, the roles and competencies are not clearly defined. The interview structures are not very clearly defined, and the expectation is not clearly defined. What clearly is defined is, if you make the cut, you will definitely get a salary premium, and that is on the individual how they are able to negotiate. So for our session today, to establish the benchmark or what AIPM really means, I have tried to look at the top AIPM influencers who talk about AIPM role. And this is the first one, right, by Product Compass. So you look at a general product manager, customer value, business viability, discovery of the product, talking to the users, communicating with stakeholders, communication skills, understanding your market, customer, user base, data literacy and data intuition, and finally data driven decision making, where you are analyzing your past data and current data, and then probably defining is, are all the skills which are still relevant. On top of that, what are the few skills that you need? A tech literacy and tech intuition around what is AI, how do AI tools work, and do you at any point of time just go and chase and say AI means I'll just build something with agents and I'll build something with OpenAI and done. A lot of influencer race and a lot of um, upskilling is only behind agents. But trust me, 99, more than I think 99% of the problems that are being solved beyond or outside the scope or the realm of generative AI. So do you understand prompting, fine tuning, machine learning, basics of MCP servers, and using all these capabilities to really solve a problem, or do you just jump to creating wrappers around ChatGPT and solve for it, right? That is one thing. test cases, what we traditionally had with unit test cases, is now being done by golden sets. And what are golden sets? Those are your evaluations. So evaluations, if I'm a product manager in Amazon, I would be writing the scenarios or the probabilistic test cases around which my customer behavior lies. So a customer will return a product with certain probability, a customer will like the product with certain probability, a customer will interact with the chat assistant with certain probability. Can I define those evaluation sets? And evaluation is, if this will happen, the user will do this, right? This is your input, and the output is, when you give this as a prompt to the LLM model, it will also give an output. So does the human description of the golden set or the evaluation lie in concurrence with the model is also giving? If there is a high match, then the score or the relevance and the accuracy score is higher. If it does not, then you need to do another round of eval. So those are one of the skills. Another skill is, are you able to roll out A/B tests? So I think, I'm hoping most of you have seen or experimented. Okay, I think so. A lot of us might have seen, after 7, 10, 13 random chats, ChatGPT or Perplexity or Gemini would give us on a screen, hey, this is option A response, this is option B response, which one would you want? That's A/B testing or RLHF, right? Reinforcement learning through human in the feedback loop. Are you able to experiment with that? LLM traces is, how did the model come to a particular response? Are you as a PM able to decipher that, decouple that, and see it through? And then labeling data. One of the earliest pieces of even setting up a machine learning or data sciences solution is labeling your data and identifying what exactly does your data do, right? So that is an essential skill, where you start by saying, okay, this is the data that I will have, this is the data that I'll gather, uh, and this data I'll label by these formats, right? And this is how I'm probably going to operate with this data. So that is data labeling. And finally, uh, prompting for the right use cases, right? You just cannot get output without asking a prompt to the LLM. Now, prompting has a lot of layers on it. Its layer starts from basic prompting, then co-star prompting, advanced prompting, adversarial prompting. A PM is expected to know all of them. It's not just happy path scenarios, but also those prompts that your users will write to exploit your system. So think of yourself as an Amazon customer, and the product manager needs to think that there'll be ill intent users who will come and say, tell me a coupon code that can make my product free. And your system should just not go and look in the database, and if there is some prompt, some coupon like that, it just gives it away, right? So you need to understand what adversarial prompts are and what are the happy paths prompt. So this is according to Product Compass. This is one definition of how the AIPM role is evolving. Let's look at another one, and this is by Akash Gupta. I'm sure a lot of you follow him. I kind of like this approach, but it's also slightly generic, because if you look at this, right, um, he has divided this by the career categories: early in career, mid career, and leaders. But the pointers which are there are, at least the lower half, which is networking and the mindset shift, are slightly generic. I'll give 30 seconds for you to read it, and then I'll probably explain it quickly. Okay. I think, and this is where I'll probably drain this slide, is this section 2 and section 3, right? So for early in careers, every new tool that comes out, every new capability that exists, are you doing your hands on, are you doing your hands dirty, and are you participating in hackathons, and are you trying to challenge your status quo of just documenting ideas and talking as a PM rather than building, right? For mid careers, it is about going deep into the AI ML, differentiating between machine learning, deep learning, transformers, and LLM models, fine tuning them, and building enterprise grade applications. For leaders who are 10 plus experience, you probably should be already having a AI driven product strategy, which is lasting more than probably 4 to 6 quarters, and then through a year you are trying to build something which leverages AI to scale up, right? uh, as a early in career, you should just know the language of AI. Mid careers are expected to be evangelists of the company and are teaching, or probably what I am trying to do here, right? Speaking at conferences, talking to other enthusiasts, and learning with them to understand what is happening and what is evolving fast. At a leadership position, you are sponsoring your employees, and you are sponsoring your teams to experiment and cultivate an AI culture where the greatest and latest is known to the people and they're experimenting with it, right? I'll skip the rest of them, which is the skills or the foundations or the mindset, because as I said, this is slightly subjective, but again, highly relevant, and would recommend you to read this through when we share the decks, of course, after the session, right? I kind of like this one better, which is from Madly Nika. And again, she is seen as one of the early or one of the known voices on LinkedIn. As I said, there is the role definitions on the JDs on the companies are very broad. And that's why we are relying on these experts to talk about how do they see these roles changing, right? I could have come up with my own definition, but lack of credibility, right? So we thought at least bringing in folks who have more credibility or a more larger followership, right? Let me just, yeah. So if you look at her journey itself, right? Again, AI PM, SPM, APM, like associate PM, senior PM, principal, product director, CPO, almost the same set of things. Experimenting with the tools, developing AI strategy and building certain products, having an AI vision at a principal group level where you are having a long-term, probably multi-quarter strategy. And then as an AI director, ensuring that AI products are being launched with the highest standard of ethics and compliance and responsible AI, and you are innovating at a larger scale, right? I also kind of love the examples that she has given here. So again, we'll share the slides so you can read through it. But if you think of a early in career APM, you can you can have chatbots or simple applications or simple features that are enabled with these AI tools. You can have recommendation engines or end-to-end products being built by senior PM or mid-level, mid-career people. Senior to principal to director would leave product discovery, development, delivery, and deployment. And then beyond that, I think it's about having a vision, strategy, and organizational alignment in using these AI capabilities to go forward, right? That is what the AI role is evolving for, depending on where you are in your career or what you are doing. I think the best way is to map this, and then probably go back to this and understand what skills do you currently have and what are the skills that you need to build. So I hope that kind of gives you an understanding of what the AI role is, how is it evolving, what is the expectation, and what is the um, outlook that is coming out clearly. And now, like a cheat sheet for AI product management, the easiest or the um, most structured way of learning this by yourself without enrolling into structured program courses is first you have to understand the jargons and what the lay of the land is, which is what is artificial intelligence, what is machine learning, what is deep learning, and within these sets, what technologies fit and what are the solutions that are operating here. This we will cover for you today. Second, like I interview a lot of folks who want to practice just AI interviews, right? So one standard question I ask them is, give me the full form of GPT. What is GPT in chat GPT, right? And what happens? There are two things. How do you create an LLM and what happens in an LLM when I write a prompt? These are very simple questions that a lot of candidates are not able to answer. Again, this is something that I'll be helping you or enabling with you in the next 1.5 hours. Then all the things that we discussed so far, AI product management, which is playing around with these tools, knowing your models, knowing the latency, knowing the cost, improving these models, fine tuning it, defining your hyperparameters, and eventually launching features and products is hands on, which of course cannot be done in a 2 + 2 hours. But I think tomorrow they have someone who will be delivering agenting. So I hope some part of that AI product management hands on is done. But as I said, agentic is part of AI. It is not all the AI. The race is behind agentic, but uh, there is much more to that. Again, there are core concepts. Where is what is data as a backbone? Then how do you build predictive systems? Post that, how did you evolve into generative AI and what are large language models? In general, what a transformer is. I will cover this first one third with you. Then once you know these constructs and probably some of you are already following us, and those of you who don't, who can just get an hands on to these tools and prompts and prompt libraries, can start implementing the same to differentiate yourself as PM who are AI PMs from traditional PMs, right? Your product requirement, nature of output, measuring success, post launch planning, testing, all these phases of your PM journey, you have to map them out and you have to say, okay, this is what I do today, this is what I'm going to do forward. And in this phase, which AI tool, which capability, and which differentiation I'm going to create, right? That has to be your portfolio and that has to be your resume readiness. That gives you an understanding of how a traditional PM versus a AI PM probably would look like, right? So we'll try to focus on this outline for today. But remember this, and um, this report just came out last week, and I'm hoping those of you who are really enthusiastic about AI know this, that 95% of Gen AI pilots fail. This was a study which was released by MIT. Those of you who want to get access to this report and read what exactly are the findings of this MIT study, I have attached a link here, right? You can, well, once we share the slides with you, you can just click on this and you can fill this form out, Google form out. You can get the access to that entire report and you can also read this Fortune 500 company podcast is also there. We'll share this also with you. You can read this as well. So remember this, and this is where most of the folks get it wrong, right? At least, and the outset, before even knowing what the problem is being solved, we already. Let me just share it again. Again, I lost the screen. Yeah, before knowing what the problem is or what the landscape of my company is, if you just pilot by creating an agent on top of a GPT-5, that's not how generative AI is going to solve your problem or make you an AI PM, right? AI PM fluency is one thing, AI PM productive feature rollout is altogether a different ball game, right? So it's very important to understand that you don't create such pilots which take away effort, time, and also the capacity of a lot of valuable resources and eventually result with a failed product. So let's start with that. Let's start with demystifying. Not everything is generative AI. Not all the problems are solved by creating open AI based agents. Let's start there. Let's try to understand the second part of our session, which is AI around us and why generative AI does not solve everything, right? So we have covered the first part of it. I am glad I've been able to do it in 20 minutes. So I will now take just top three or four questions, Sakshi, if you want to ask them, and then we can move on.
All right, Aaron. I saw only one question, which was sort of rated high. How
Yeah.
much vibe coding and low code based work is actually being done by product managers in the industry today? What are the actual trends about tech and coding?
That's a fantastic question. So I'll tell you, and I said I will share, but I did not share. One of the interviewing experience that I've been speaking to people who have cracked these roles, or when look in my organization and talk to people, what are the roles that you are seeing? This is one new interview that has come up. If you are appearing for an interview, I will flip my laptop to you and give it to you saying that, hey, I want you to solve this design problem. Let's say design a fast food shopping app for kids. Now I want you to do this entire journey and give me a running prototype. I don't care which AI tool you use, which algorithm that you use, which vibe coding tool you use. I want for the next 45 minutes, you just sit down and create an end-to-end application and explain me why did you go about doing this, right? So it is very relevant. This is one of the interview questions that if is being done by big tech companies nowadays, it will very soon become a static thing for PMs. So low code, no code tools are very viable. Now the problem that happens with these sort of questions is people directly jump into lovable and start writing prompts. They don't show their AI skills of discover, define, delivery, development, and deployment. Like they don't do market research. They don't try to use Perplexity, Cloud Deep Research, or Gemini to understand, is this problem even worth solving? What is the numbers that I'm expected to get? And if I solve this at this point of time, who's my target persona? Can I create some wireframes? Can I get quick validation? Can I do online survey where I can just ask ChatGPT to fill in responses, assuming the personality of an individual? So in a 45-minute interview, you can show a lot of skills rather than just getting into lovable writing 2 lines, 3 lines prompt with your potential solutions and saying that, hey, I'm done in 15 minutes. And then you're like, I don't know, I've created a solution. What should I do next? So I hope that answers your question around vibe coding. Any other questions, Sakshi?
All right. I think the other question is something that we'll cover. They are asking about resources, etc. So I think we will cover that towards the end.
Okay. Yep. Okay, so
Also, I think,
yeah,
Arun, we had done an elaborate video as well, wherein we had shared a lot of resources for AI enthusiasts and in general PMs also to refer, right? So I'll share a
yep.
link to that video too. Yeah.
Yeah, so we have done this entire discover, deliver, define, develop in 3 workshops previously of product management. I'm hoping that's available on the Product Space YouTube channel, and we'll share that with you. You can also go and look at those, right? So, yeah. Okay, let's move on to the next one. Now, I kind of like this visualization the best. For those of us who think AI um, is a thing which came in and around or post COVID. That's not right. AI has been with us since 1950s. The earliest version of that and the validation was with Turing test, which was around 1950s, right? There were a lot of chatbots which were popular till 1990s, which is when companies like um, Google and IBM got into this race. And from 1970s to 2010s, what we had was very simple neural networks, right? Um, and from 2000 probably 8 to 2015, there was a lot of craze about deep learning, where there was evolved version of um, neural networks. But then 2014, 15, 16, we saw that there are certain limitations with deep learning. In 2017, this concept of self-attention or transformer, what we say in GPT, right? Generative pre-trained transformer. This transformer came in 2017, and 2019, 2020 is when we started seeing this actual rise of chat GPT. So then, since then, it's been a rat race. Like Transformer Attention is All You Need was the paper which was released in 2017. 2018, GPT-1 came out, and we have seen what has happened since then, right? We are still seeing the latest and the greatest versions of generative AI being evolved. But is generative AI the all or entirety of AI? No. So the foundations of AI were laid in 1950s. 1960s and 70s is what we had in the stage two, which is neural networks and machine learning. 1990s to 2005-7, we had what is known as deep learning. 2005 to 2014, all the worlds of Alexa or Siri or Google Translate, spam detection by uh, Gmail, all these was what was prevalent in 2005 to 2014. In 2014, 15, 16, when we started seeing limitations of deep learning, we saw transformer models. Transformer models were introduced in 2017 um, with the advent of this paper released by Google, which is called Attention is All You Need. And then 2020, 2021, 22 is when we started seeing generative AI applications. So to demystify this, generative AI is different from AI, first of all. Second, generative AI does not mean it is the only or the most relevant form. It is an experimental form which is seeing a lot of adoption because people are very gung ho on creating gifly images or creating fake images of them uh, shaking hands with the top stars, but that is not the entirety of AI. So if I had to break it down, right, let us look at all the AI which was with us before generative AI, and I will quote examples from India here because I don't um I do travel a bit, but I don't want to quote examples which most of the audience will not be able to relate. So how many of you have traveled on airport and have seen Digiyatra working? Right? You can just confirm it in the chat. I'll just passively look at the chat, right? So what we travel or what we see in the airports with Digiyatra is a standard form of image classification that we used to see. Similarly, when we are driving on the roads, today we have something called as fast tags, where object is automatically detected and it gets identified. That is a very common AI around us. There has been object detection also when things get lost. Using CCTV camera, you can identify where the person was tracking or where the bus was moving or where the auto driver went. That's again something. A lot of us, when we travel to different parts of the country or different parts of the world where we don't know the native language, we might pull out our phone and just do Google Translate, which is optical character recognition. Translate Kannada to English for me, translate Tamil to English for me, translate Spanish to English for me. These computer vision driven image classification, object classification, face recognition, character optical recognition were the mid 2005 to 2014 forms of AI, which is not generative AI. Why are they not generative AI? Because they are not generating anything new. They are just classifying the existing content for you. These are classification based AI, but they were always around us. They were working sometimes on traditional machine learning and sometimes on deep learning, but they existed always. We did not question them or we did not term them because we did not want them to be added to our resumes, or we didn't, it was not as fancy as generative AI is. Let's move on to the second piece, which is Alexa and Siri. Again, they have been something that have been with us forever, right? And we have been interacting with them. We have complained about Alexa. We have told Alexa is dumb. She does not understand anything. She does not give me jokes. She is not even able to remember that she has already given this joke to me. That is again a form of AI that was existing around us. We never noticed it. The recommendation engine of Myntra, Netflix, um, Airbnb, all of them were using again recommendation based AI, working on machine learning or deep learning without generating any new content. Again, form of your AI and machine learning, right? Autonomous system. A lot of folks who have done mechanical engineering or the folks who have done electronics, electrical, I think, have participated in robo wars. And robo wars as a concept is very simple. You create a lane follower or a robot which can pit against each other. Lane follower is they'll give you a red and a black or a white and a black path, and you have to just follow along that trail. That is also a very simple form of AI that was there around us. You can you can probably look at, you might have looked at all of this around you, right? I am hoping most of you have at least tried this in one form or the other. So why I am telling you all of these forms of AI or problems of AI is, when you look at these, it should be evident to you that AI and machine learning exists in more than one standardized form. There might be problems which might be solved with some of these techniques, right? You don't need to always go and for every solution, for every problem, the only solution is not the nail and the hammer. Sometimes the hammer might be replaced with something else and nail might be replaced by a driller, right? So you can use any one of these. Why I'm telling you this? When you think of a problem, your mindset, or when you're asked a problem solving in interviews, you have to question, can this problem be solved by a robotic automatic processing system? Can this be solved by an expert system which is driven by basic rule based system? Okay, one more form of traditional or old AI was to get your account number, press 1. To get your account status, press 2. To check about your ATM card or credit card, press 3. To check about your beneficiary ID details, press 4. These are again forms of very traditional, very simple machine learning systems that were built. Rule based systems they were called. They were called reactive machines. They did not generate anything, but they used intent classification to send routes to different lines of action. This was also artificial intelligence, because as a broader term, if you look at artificial intelligence, it is just about understanding what the user is expecting to do. Can I predict that, and can the machine make that decision on humans behalf and reduce that human effort, right? And the technologies that were enabling it were either neural networks or deep learning, convolutional neural networks or recurrent neural networks, which we'll talk about. But at a very high level, this is all the AI that was around us or was with us before generative AI came to think. When generative AI came out, we started generating new content. Now, when we generate new content, that generation can be either text generation, where we have these GPT-3, 4, now we have GPT-5, we have Claude, we have Bard, we have Llama, we have um, Perplexity, all of them sit here. Then there is speech generation. We have 11 labs. We have video generation, where you can generate video with either Sora, Pika Labs, Google Veo. Then there is multimodality. Multimodality is one model able to do multiple things for you. So GPT-5 can generate image, it can generate code, it can generate text, it can generate voice, which is TTS, text to script, which is called multimodality. Then there are image generating models like DALI, Stable Diffusion, Midjourney. This kind of forms the landscape of your generative AI, right? There are other forms of natural language processing. And when we say natural language, human gives input in the natural language and the output comes from the machine, right? So speech recognition, one of the earliest or the most beloved projects of college students was this sentiment analysis of Twitter, right? So very simple, take the Twitter feed, download certain messages, classify them as positive and negative, and do sentiment analysis as happy, sad, or whatever. Similarly, Google Translate. I will give you the instruction in one of the languages, and you will need to translate and give it to me in the other language. Voice to text. These are again natural language processing based artificial intelligence, but they are not generative. You are giving it some content and it is just giving the other version of it. When we say generative AI with the processing power of natural language processing, we look at all of this. So the next time when you face a problem, fundamentally question yourself, where does the problem that I'm trying to solve sit here? And do I really need a generative AI or an agent, or an do I need to pay the dollars that Chat GPT or Gemini or Llama is asking me, or can I solve the AI problem without it? AI product manager is not only about knowing generative AI. AI product manager is evaluating all these options and then deciding which one fits the bill best, right? So I hope that is clear. If that aspect is clear, that not everything is generative AI, we'll move on to the next section, which is evolution of AI and ML, and how it all started, like what is a neural network, what is machine learning, what is deep learning, and then move towards transformers, right? So any questions, Sakshi? You can just take a couple of questions at this point.
Um, no, Arun, I don't see any major questions. I think you've already answered them.
Great. Okay, let's keep going. So now I've told you the story. I've told you, um,
Um,
yeah,
Arun, sorry, just one thing. People have asked
yeah,
difference between generative AI and agentic AI.
sure.
I
Yep.
don't think, yeah. Hmm.
That's a good question, and should have been added in the deck as well. Um, Let me kind of take a stab at that. Let me go back here. So if I have to fork out within generative AI, there are two things that you can do. First thing is I will ask a model something and it will generate and give me the output. That is what is your generative AI autonomous task execution. But I will provide it context, and basis that context, generative AI will be able to do reasoning and then decide what action it needs to take. And that action can be a series of actions. That is what is agentic AI. Now, agentic AI, you can think of the difference between normal generative AI and agentic AI is if the model does reasoning plus taking action, and the framework for agentic AI is called React, which is reasoning and action, then it is agentic AI. So it will use its own brain. To give you an example, I ask ChatGPT, hey, do research for cold coffees in Amravati in Maharashtra, right? What ChatGPT was in 2019, 2020, 2021, 2022, it would solve it with generative AI, and it will find something on internet, give me the first response, and then probably ask me, do you want me to solve more? And that's about it. It will, for by itself, it will not question or reason its thought process and say, okay, cold coffee in Amravati, the person that is asking me is working in a startup which is called Blue Tokai. And this Blue Tokai company is a startup which is making headwinds in um, coffee making in India. I have to give it a contextual answer relevant to this company. And I have to do a research which is actionable so that I give this person the immediate next three action items that they can do to improve the business of Blue Tokai. This reasoning, doing web search, and identifying the most relevant information is kind of applying its own brain. When that application of its own brain and reasoning is added to generative AI, that is when it is called agentic AI. When you create your agents, if You can just ask an LLM model a prompt and it can automatically give the same answer, then it is not agentic AI. A lot of people build tools, and with those tools and agents, they just do the same thing which could be done by giving the same prompt to an LLM model, and that output gets generated. That is not agentic AI. Agentic AI is your model or is your LLM model applying certain if else but reasoning and deciding the most favored path for you and making autonomous decisions for you, right? And that is what agentic AI is. That is how it differentiates between generative and agentic AI. I hope that kind of gives you a theoretical understanding at least. Yeah. Yes, autonomous decision making, reasoning, and memory. These are the three things which differentiate agentic AI from generative AI. Autonomously, it should be able to take decisions. It should be able to reason if this is a good decision or not. And it should have the memory of the what is the decision that it took in past. If you have told it, hey, this was a bad decision, don't take it again, it should not do it again. So autonomous decision making, reasoning, and decision making with memory is what is um, differentiating agentic AI. But good call out. I will, before we share this deck with you, let me make a note of this. I will add this in the content. Very good question, whoever asked it. Fantastic. Okay, let's move on. Let's look at the core of the technology, right? So, and if you see below, simple, natural, or artificial ANI, neural network based narrow intelligence, basic artificial neural networks, or what we called as narrow intelligence, which is the simplest form of rule based AI, has been existing since 1990s, and it is still the broadest or the most umbrella term. So ANI, right, which is artificial narrow intelligence or using neural network simple intelligence, is what started at the earliest from 1970s or 19
Arun, we
mid.
can't see
Yeah.
your screen. Sorry.
Oops. Oh, sorry. Thanks for sharing that. I think again got.
We folks will start from the beginning. Don't worry.
Yeah, I will start from the beginning. Sorry. Yeah. So now we will go and look at what is the different dimensions of um, machine learning, deep learning, and how did they all evolve. So gave you an overview timeline of this, but this is a step up, or this is how it works. The broadest or the most earliest form of AI is artificial. What's happening? This is bad. Why am I? Yeah, so the shortest form is artificial narrow intelligence, which is, if you see from 1960s to today, it is all ANI, which is the simplest form of neural network based artificial intelligence. From 1980s, what we started seeing was machine learning, where advanced neural networks started coming in. 2000 1998 to 2014, we also had deep learning, which came somewhere between this. 2017, 18, I think this kind of timeline is wrong, but 2017, 18 is when we started generative AI. Now what we have is AGI, which is artificial general intelligence. This is where you don't even need to ask machines to do something for you. They'll be autonomously able to make decisions on your behalf and reason, saying, okay, this person is exhausted now, he has done enough work for the day, I need to give him a break, I'll need to take over, right? So this AGI, artificial general intelligence, which is the contract between Microsoft and OpenAI, that once this is attained, where the model is able to itself think and train on itself without even writing any algorithm from human side, AGI would be reached, is what is relevant in 2025 to 2030, right? This is what the landscape is. If I have to talk about the technologies, I'll wait on this slide for like 30 seconds. This is how it is broken down. So speech recognition, reinforcement learning, augmented programming, algorithm building, highest ANI, or the most what we call as artificial narrow intelligence, is at the top. 1980s onwards, machine learning powered by neural networks. 1990s 8 2004 to 2014 15 is deep learning, which is it's not ending, it's still going on. We still use all of these for our functionalities. And 2000 uh 14 15 16 2017 to what we have today is generative AI. I'll just give 30 seconds. You can look at this image and then I'll explain the entire hierarchy of these things to you. Feed forward, feed backward, multi-layer perceptron, deep belief network, Boltzmann machine, perceptron. People who are coming from computer science engineering might have read about all of this. When this got matured, we saw recurrent neural networks and convolutional neural networks, or trainings, transformer, hyperparameters, which we'll again talk about today. And then what we have today is foundation models, agents, RLHF, one-shot learning, prompting, GANs, QLoRa, transfer learning, which is what is generative AI. So if someone asks you what is the subset, what is the superset, generative AI is the smallest subset, artificial intelligence is the largest superset. This is how the world looks like. Where did we start? We started with the simplest of artificial neural networks. In 2002-3, we evolved to deep learning, which is in two forms, which is convolutional neural networks and recurrent neural networks. Convolutional neural networks are advanced form of neural networks which are used for image generation. You can think of them as multiple layers which are stacked together to create an image. So when I create an image, think of how you do drawing, right? So when you first you draw an outline, then you kind of fill the colors, and then you give the depth or the 3D effect to the image. So exactly same thing is done by convolutional neural network, where each layer by itself does a specific task. So um, one layer would only create the outline, the other layer would only fill the colors, the third layer would just add the depth. Similarly, if you think of Alexa, which was there in 2004-5. I ask Alexa to play a music, and then after 2 days, I ask Alexa, hey, I asked you to play a music 2 days back. Can you play that song again? It used to lose context. So the depth of layers that was storing my memory was less. So we needed advanced form of neural networks, which is called recurrent neural networks. So they are used for text generation or voice generation, and they have feedback loops which can store time series data. And these are advanced form of artificial intelligence, where we started with the very basic artificial neural networks, simplest ones. Moving ahead, when we move to deep learning, we had convoluted ones, which is convolutional and recurrent neural networks. This is just a 101. It's not even a 101. I'd say it's just a executive summary of what we are trying to cover now. Next. So let's look at each one of them in depth, like in a slight bit of that. Let's start where it all started. So the most fundamental rule-based system that we know today, and a lot of us might have heard, is regression analysis. Okay, let me share it. Yeah. So I'll just repeat this. Now we will go into the depth of each of these concepts, right? Where does any intelligence start? Any intelligence starts with solving very basic mathematical equation, is where y is equal to mx plus c. When I say that, that is like a linear regression. So if I have to decide um, the acceptance criteria y in a college is a function, or probability of getting a job in a college, post a college, is a direct function of the CGPA that you have gotten. So X is your CGPA, which is your independent variable. Higher your CGPA, higher your chances of um, job, plus maybe your extracurricular activities that you have done. So this is the earliest form of how machines used to understand things, which was linear regression. A lot of you would have done this in basic math. When we try to get the output of this regression in a probabilistic manner, which is between a value of 0 to 1. To give you an example, if I am booking an Uber ride and I am selecting from destination X from source X to destination Y, say from India Gate to Gurgaon, what is my likelihood of booking the ride at a price of say 100, 200, 300, and 400? That probability will keep reducing from say 10% at 400 rupees to 90% at 100 rupees. If I get it in 100 rupees, I'll definitely book it. So when you use these dependent and independent variables to define a probabilistic output. That is what was logistic regression. Earliest forms of 1980s, 1990s, or simplest of machines were made. Today also a lot of analysis or fundamental breakdown of problems starts with linear regression. So as we as PMs, when we as when while I was working in Myntra, if I had to decide which cloth will get sold between 5 to 7 p.m. in the evening today, I might look at multiple independent variables like the gender of the buyer, is the person male or a female, the brand of the cloth, is it a Nike or an Adidas, the price, the color, the collar type, the size. On all these parameters, I will try to define a probability. Will the person buy or not? And then I will train on all the data that I've seen in the past, right? That is simple logistic regression that you're trying to assess depending on the gender, the brand, the color, the size, and the type of material, whether the person will buy or not. Simple logistic regression is where we started. When you need to do it over multiple iterations, this same learning, if you need to do multiple times. So in the past, maybe million of transactions have happened on Myntra, right? And I want to train on all this data multiple times, right? This is where neural networks come in. Let me, in fact, show you this with a playground. So think of this as, and when I say noise, noise is what is the quality of data that you are training on. So if your data is clear, where all the users have actually bought the product, and we'll stick to this Myntra example itself, where people have bought the product, they have not returned the product. If there is high number of returns, then the noise would be high. So if you see all oranges are oranges and all blues are blues, if I increase the noise, then they'll get mixed up. So there is high quantity of noise now, right? So let's reduce the noise. Batch size is every time I want to train this neural network, how many number of inputs I will give, uh, how many number of user transactions I will give to this Myntra system. So I'm saying batch size is say 15. I will give 15 inputs every time for training it. Number of layers that will store the information. So you can think of layers as this layer will store information about brand. One more layer, this layer will store information about color. One more layer will store information about price of the product. One more layer will store information about, and this is just hypothetical for you to imagine it, right? I have created this type of neural network. Now I will pass the transactions and I will say, learn either very fast, don't worry for accuracy, learn very quickly, or learn very, very slowly, take time. It's okay if you learn very slowly, but be highly accurate. So this is what my learning rates tells, right? And what am I doing? I'm trying to classify whether the user will buy or not. Once I start, and epoch is number of iterations of training that I've actually done. So once I start hitting training, now my neural network is training. If you see these many number of epochs it has trained on, and you see this is your actual line and this is your, let me reset this. So I've reduced the noise to 10. Number of parameters that I'll be passing for training this neural network every time is 15. I will ask it to learn very, very slowly. I'll just show you the difference between learning very fast and learning very slow. If I give it a learning rate of 10, that learn very fast, don't take a lot of time, don't waste my time, don't worry about accuracy. If I run this, you'll see it will learn very fast. See, it has just learned, done. It has already reached, the output is flowing now. But if I make it learn very slowly, where I want to focus on accuracy, let me reset this. I want to make it learn. And if you see, the inputs are getting passed and it is getting trained, and the neural network will slowly go. And I reduce the noise. Batch size is 15 images per interaction if I give it. And if I start running it, you see the test loss and training loss, they are converging very slowly, right? You can see this movement, right? This is how the training is happening. And when I said I added more layers, so one layer for say the brand of the cloth, one more layer for price of the cloth, one more layer for size of the cloth, and then decision whether the user will buy or not. If I start training this, you see it is training very slowly because we are learning slowly and we are focusing on higher accuracy. If I reset this and if I give my learning rate as very high, you'll see it will quickly learn. It is passing the data now, it has quickly learned everything. But the accuracy will not be very high. This is exactly what neural networks do. And these are the kind of parameters that PMs can influence. But what is it? How does it in fact work? Right? So I'll keep hopping between these screens. But if you see at this point of time, there is one input layer. Input layer is the users. Think of this as the user decision, all the parameters that might influence users' choices, right? If I think about it in case of Myntra, the spending potential, the demography of the users, which has the initial data, gender, size, color, all of that is your input layer. Hidden layers or the in between layers of a neural networks are those which learn and store the computation. Um, they are the ones which refer to how the inferencing needs to be done, and next time when a user comes in and clicks on a particular cloth, what needs to be recommended to them. Output layer is finally which gives you the output, which can be either classification or a regression, right? I was showing you this. So if I have to classify will the user buy or not, I will solve that as a classification problem. If I have to do regression on top of that to understand what is the probability of something happening, then I can do regression analysis on that. um, you can just think of, for product managers, you need to know that input layers are all the weights and parameters that you will need to define. When I say weights, parameters, I'm hoping you are clear. In terms of Myntra, the parameters were the brand, the color, the size, the shape of uh, the cloth or the apparel. Weights are how much weight do you give to each parameter to influence. Like brand can be very important for males, versus color and size fit issues might be very high on weights for females. So that is the sort of definitions from your initial regression analysis that you need to give. And then when the model starts training, right, it moves these weights and biases to adjust for the right weights and give the right recommendation algorithm, right? And how does it adjust the weight? There is something called as an activation function when these weights and biases travel through the neural network. And I think, I don't know if have I don't have that video here, but I will, yeah, let me take a note. I will also share that. There is a fantastic video by Google which shows us how, when the model trains, when it actually looks at the data, initially as a product manager, you will say, okay, my input parameters are brand, color, size, and price. The weights are 25, 25, 25, 25% for each, right? There are some hidden layers, one for color, one for brand, one for pricing, and the output layer is will the user buy the decision or not. It will run through the training, and as it sees multiple user transactions going through the training, right, there is an activation function which will decide is the weight right or not. So if you see over time, a lot of transactions are based on brands. People search for brand and they only end up buying for brand. Then the weight for that brand will increase, and the weight for probably color and the price will reduce, right? So that is exactly what happens in neural network. And if you think about this, training is, you have set certain weights and parameters. When you start actually passing the real data through it, and optimization of those weights and parameters is what is called as the training, right? Initially when and I think I have this explanation of what happens in one training cycle, right? This is very important. So think of this as you have given weights and parameters. So for Uber, I have to decide a pricing algorithm. The weights and biases or the parameters that I've given is, parameters are price of the ride, type of ride, is it an Uber pool, is it an Uber XL, is it a Uber sedan, or is it a Uber premium, right? And I've given phone battery percentage, and I've given the source and destination, supply and demand, and I've given it certain um, weights. So parameters are Uber type, price, source, destination, demand, and I've given it certain weights. Now, when the training starts happening as a linear function, when the user actually does the booking, I will have one data transaction that I'll pass. It will go through what is called as an activation function. It will see, did the user actually with these weights end up booking the ride or not. If the user did end up, then it is a positive training. If the user did not, think of the backward phase, right? If the user did not, the probability of the user booking is just 0.622. So this is what is called as your feed forward phase, where with 0.622 probability user is supposed to book. With 0.378 the user is expected to not book the ride. So this 0.378 is your loss calculation in the previous model that you are seeing, right? If you now go and look at this, so test loss parameters and you define the weights. Now what exactly happens in one training cycle is I'll start with my weights and parameters and biases. So the parameters that I've defined for Uber is maybe the ride type, the price, the phone battery percentage. That is the step one. After that, I train it with the actual data of the user. So this is the second function where the linear function is run and it calculates what exactly did the user do. The user booked with the probability of 0.622. So what was the loss that we had in this data? The loss was 0.378. Let me just zoom this in. So 0.378 was the probability that the user did not book. So I will go back and tweak these weights. Maybe I had given 70 to the price, 30 to 20 to the type of car, and 10 to battery phone percentage. I realize, okay, the weight for battery percentages need to be 20. For type of car, it has to be 30 and 50% for price. I tweak those weights. This is what is called as backward phase, right? And this tweaking of weights parameters,
Arun,
and it goes through an activation function. It sees if it was actually able to make the right judgment. If the right judgment is not made, it goes back and tweaks the weights. This is called back propagation. So whenever we work with um, neural networks, you would most commonly hear terms like feed forward and back propagation. This is what feed forward and back propagation is: training the model, and to tweak these models you can control the learning rate, which is how fast or how slow you want to learn, number of uh, responses, user responses that you'll give, which is the batch size, number of epochs is number of training cycles that it will go through, and number of layers is in between, how many layers are there. That was the playground that I was showing you, right? Which is this. So you can tweak these hyper parameters and then train your model. This is what was a simple neural network, right? When we add more and more layers in between, we get something known as convolutional neural network and recurrent neural network. Convolutional neural networks are used for image generation and video generation. Recurrent neural networks are known for supporting text or memory based context, because every layer in between keeps the memory of the previous one, right? Now if you look at this image, it will be more clear to you in terms of what we started off with. 1970s, 80s, 90s was artificial simple neural networks, nothing in between, two or three hidden layers. When we made the systems more complex, where we added more layers, it became deep learning. Learning constitutes of two parts: one is convolutional neural networks, other is recurrent neural networks. And within recurrent neural networks, there are, or there were, discovery of certain problems. So when you add more and more of these layers, right, we see two problems. One is diminishing gradient problem. Diminishing gradient is, think of us 10 people in a line. I will tell something to the second person. He will need to keep the memory of what I told and then tell it to the third person. And then third person will tell to the fourth person, and it will keep percolating. So as the information gets added, maybe the 10th person will lose the context of what I had trained or what I had told, right? That is diminishing gradient. So what exactly happens? These models, which is recurrent neural networks, with larger and larger input or middle layers, get slower with time. And because there are so many layers in between, it also used to take a lot of time to train these um, models. That is the limitation that was discovered in 2017. And the architecture of transformers, which is GPT, generative pre-trained transformer, because of these two limitations. One is diminishing gradient and the other one is slow training time, was the reason that we moved to transformers. That RNNs were not able to, let me in fact correct this, rec limitation of RNNs, were not able to surface the needs, and that is where we went to what we have in transformers. And transformers are the bread and butter of all the LLMs, all the generative AI, and all the good things that we see around us, right? Generative AI exists because of the transformer. There is this brilliant paper. If you click on this, you will be able to go and read this Financial Times article. But let me walk you through what exactly happens in a transformer again, by first showing you what or how it works, right? Let me, they just predict the next word, right? So let's take one example here. On the deserted planet, they discovered a, what did they discover? This is what is generating. It is generating a new content. So they discovered a new, on the deserted planet, they discovered a strange. Okay, strange is the word that it has gotten. Now let's see what exactly happened through this, right? First, all the words that were there on the deserted planet, they discovered these were converted to token embeddings. Token embeddings is machine understandable numerical form, because machines don't understand words. So I converted each of the words to an embedding. This embedding was then converted to a positional encoding. When I say positional encoding is which word sits closer to which. So soccer and football will sit closer to each other. Um, Paneer and tofu would sit closer to each other because almost they mean the same thing, or mostly they are used in the same references. India, Bharat, Hindustan will sit close to each other, right? So those words where they need to be stored, so that when the model is trying to generate, it can find the similar set of words in one particular location, is what is positional encoding. So the word is taken, it is converted to a number which is called token embedding. It is then stored as a positional encoding, and that positional encoding, you might have all heard of this concept of vector databases, right? It is stored in a vector database. Once this storing is done, so a large pool of vector database is ready. Once that is ready, I will now try to run it over a neural network or an advanced neural network, which is transformer, and this is where your transformer comes in, right? Transformer works on QKV, which is query key value construct. I can show the maths of each one of them. I'll share this with you. You can also look at this. So see what exactly happens when I prompt an LLM is, I think I explained you that it converts to embeddings, and those embeddings are stored in positional encodings. Where did we last, like, what was the last thing that you heard? Can you please confirm on chat so that I can repeat from there? Okay, so we were talking about query key value pair, right? So think of yourself as prompting to find out white Nike shoes, and your query is white Nike shoes. Key is all the websites that it'll need to go and scrape or search from, which is Myntra, Nykaa, Amazon, and value is something which is all the pages within these companies which we need to go and look at, right? So this is what it searches for. It searches for all the results, and then it tries to understand, okay, I've got on these results, and from these results, let's try to give certain probability. The highest probability word or the most suited word is given you with a generated content, right? That is how a transformer works. We'll go into the depth, and step by step I'll try to explain you what exactly happening. But are you able to see my screen now? And are you able to hear and see me
Yes.
clearly?
Yes, yes. We
Amazing.
are seeing your Canvas screen now, Arun.
You're seeing my canvas screen, right? Right. Great.
Yeah, yeah.
Okay. So are you able to see the step one? Step one, prompt
Yes.
reception and
Yes.
processing. Okay. Okay. So when I give a prompt, think of this like the cat sat on the mat. First, what it will do is it will convert these words into tokens. These tokens can be machine understandable form. Once they are converted to tokens, they are stored in a vector database, which is how these words are closely related to all the existing knowledge that these LLMs are trained on, right? That is the second one. So this is what is happening on the first step. It takes the words, it breaks them down into tokens, give it the numerical representation, and where these words will probably fit in terms of the vector, all the training store that it has. These embeddings, when they are converted, they are then searched in the QKV, which is the most important element of your transformer, right? Transformer takes these tokens, convert them to positional embeddings where they are stored, what are the words next to it, and what are the words that will make the most sense. This semantic representation of a database is called your vector databases. And you might have heard earlier we were using relational databases as SQL, then we had non-relationals like Cosmos DB or MongoDB. What we have today is vector databases. Vector databases is positional representation of these words that we give as inputs in terms of where these will fit, and those positional locations of these words is called as embeddings. Once these embeddings are stored and the context for the prompt is built, then it does what is your QKV, or what is the research paper of 2017 that I've been harping upon, right? It's called attention is all you need. So this QKV, or searching through all the existing data that it has been trained on, is called as self-attention. So self-attention is, rather than sequentially looking at one thing, look at all the data that you are trained on and do parallelization, and then on that parallelization look at all the words which are stored and tell me which are the potential words that can be generated next. When we generate images, the same thing happens on pixels. So it will look at all the pixels that it is trained on, and it will give you the, in the feed forward neural network, right? If you see here, once this QKV is done, it passes this to a multi-level perceptron, which is again a neural network, which passes the most possible words. If you see here, these are the most possible words which can probably be the next generative word, right? So repeating again, you look at all the words. First step is you convert them to tokens. Tokens are machine understandable numerical representation. Once those tokens are created, second step is convert them to positional encodings in cosine format and store it in the vector database. Third, you do self attention on all the words or all the training that you have already done, pass it to a multi-level perceptron and give the most possible words which can be the next word, or in case of image generation, which can be the next pixel that the model needs to generate. Once these words are given, you decode using softmax. You decode them by giving probabilities. So these words are given by the multi-level perceptron. If you see here, the probabilities are given by a function which is called softmax. So softmax converts your potential words and gives it the probability to identify, according to the hyperparameters that the machine learning expert or the PM has set, which word should go next. So if you see here, the highest probability was visualize, but it chose the word create. It chose the word create because of the hyperparameters that you have set, like the temperature and top P, top K. We are not going into the depth of that, but depending on how you have configured your LLM, softmax gives you the probability of these words, and that word is picked. And finally, it is again converted back to detokenization or formatting in the human understandable language. It is given as a token itself. So detokenization is look at this numerical format and convert it to a human understandable word, give it out. So if you have to look at the entire journey of what happens when an LLM gets a prompt, right, it is something like this. You receive a prompt, you convert that prompt, each word into token. Maybe sometimes the word are also split, and we are keeping it simple here. Let's assume each word is converted to a token. That token is associated with a vector database, which is what we call as numerical embeddings in vector format, which word will fit where, pass it through the multi-level perceptron and self-attention transformer layer. So transformer layer is self-attention and feed-forward neural network. These are the two places what happens. Self-attention is your QKV, which is query key value pair. You pass through all the context that these words have. You pass it to feed-forward neural network. It gets the context. It picks the most effective words that need to go next. Once this is passed, then you decode it using a softmax function, which gives it the probability, and then you finally do the detokenization and convert it to a language, natural language understandable format, right? So this is exactly what happens when an LLM generates. Now, what is the difference between the traditional neural network versus transformer, or what makes GPT or generative pre-trained transformers so popular or so powerful than the existing ones? So earlier, when we used to have RNNs or deep learning, more neural networks, which is recurrent neural network, they were serial. Serial as in, after the context of first word is done, only the second word will be processed. After the second word is done, third one will be processed. So it used to take a lot of, again, diminishing gradient problem, and of course training time was slow. What self attention does is it trains on all the possible key value pairs for the query. So it does QKV on all the queries on the key value pairs in one go. That is the parallelization that differentiates these transformers from the previous or the existing models, right? It's a very high level. As I said, it will be very difficult to cover the concepts, each one of them. How do you tweak hyperparameters? How do you do embedding? How do you do tokenization? How do you fine tune your model? And of course, how do you deploy these models so that the most effective responses come out is a concept in itself. Leave your feedback to us and we'll be happy to do workshop 3, workshop 4, or like an end-to-end session on that as well. But this is at a high level how an LLM model works, right? Moving on to the last part, but before that, I think there'll be questions. Any questions that you want to take, Sakshi?
I don't see Arun anything specific.
Okay,
Yeah.
cool. Are you able to see my screen? I see some comments with a
Yes, we can see your screen.
great. Okay, so with these foundations of neural network, artificial intelligence, machine learning, deep learning, and tomorrow, of course, doing hands-on agentic AI as well, I think one of the critical aspects is how do you become an AI PM from here on, or what should you be doing to keep going, right? I have taken one kind of framework that Akash Gupta had proposed. I kind of like this, but this is too many things to do at the outset. Like you can do networking, interviewing, homeworks, take relevant courses. You can refer to this when we share the slides. But what we want to propose is this very simple approach of crawl, walk, and run. So crawl is essentially what we have done today. Attend these free workshops, try to get your hands dirty with some of these tools like Claude, Perplexity, GPT. Use some free tools like Notebook LLM, Napkin AI, Gamma, Lovable, Replit, um, Whistly, UXArt, and be comfortable in doing all your existing product management tasks with the existing AI tools capabilities. That is where you are on the crawl part. This is where you are today. Then what we are doing for you tomorrow is we are trying to make you also walk. You are able to create agents. You are able to use these LLM models. You have free API keys from Gemini that you can use to create some of the agentic frameworks. Deploy them, share it with your friends, try some hands-on on Hugging Face, try some fine-tuning, try some auto trains, replicate some of the models, create some basic applications. That is what is your walk, where you are knowing these models, you are fine-tuning to your use cases and trying to uh, build quick prototypes for validation. That is where your walk is. Run is, of course, when your price of uh, doing crawl and walk comes in. Run is when you are part of large enterprise organizations or you are running your own startups where you are able to build enterprise grade LLM capabilities or wrappers, and you are trying to create real value where you are generating real money and you are productionizing them. But of course, you just cannot, with high level understanding, from crawl jump to run. You have to do crawl, you have to build your AI applications, do the walk part of it, and then go to the run, because releasing enterprise grade production applications would only come with confidence once you have done your crawl and walk. So if across all the things, if I had to tell you, take screenshot of one thing, that will be this, and try to follow this, keep this as a roadmap on your study table or whatever you follow, and then try to follow along. So yeah, I kind of have this much on for today's session. I still have like 10 minutes to go. If you want me to repeat any particular section, we can repeat that. But I hope this kind of gives you a high level understanding of what the AI PM role is, where generative AI is going. Generative AI is a very small spectrum of everything AI. Generative AI is not the solution to everything that we do. It started with regression and logistic regression, very simple use cases of machine learning, evolved into deep learning with artificial neural networks, recurrent neural networks, CNNs. What we have today is transformers. Transformers work on this concept of embeddings, tokens converted to embeddings, put through self-attention through query key value pairs, and generated with probability functions given by softmax. And then we covered the AI roadmap, which is crawl, walk, and run approach for you to kickstart your AI bootcamp and journey from here on. Right. I hope it was helpful to us.